My name is Yannick Saint-Hilaire. I went up in a small town called Carrefour, Port-au-Prince, Haiti. I majored in psychology, but soon I began to get interested in coding. In Latin America, it's complex for women to get interested in technology, and in my country, to start a career in this industry seemed impossible. But it isn't. Soon enough, I found many women passionate about technology, a community of women with a great purpose.
My name is Maria O'Brien. I'm from Trinidad and Tobago, and here in the Caribbean, we face many complex problems. But I'm happy to see that each day there are more women joining the movement. In my life, I've experienced much pain and loss, but that made me focus on helping others. I believe that mental health and self-care is the most important work we have. If I could learn that, I'm sure that by sharing my experience, it's worth it if I can help anyone. Women Tech Makers is a community where we can share knowledge and resources. We can help each other grow. In time, I've learned that together, we can face any obstacle.
Being a part of the Women Tech Makers community helped me gain self-assurance, and it also helped me make decisions.
Being a Women Tech Makers ambassador allowed me to meet other women in Latin America interested in different areas of technology. I get to meet and motivate other women in the Caribbean in their search of new possibilities.
I learned how much impact we can make on the community. In this context, learning how to listen and actively collaborate helped me to achieve different goals, to go on beyond all obstacles. Join the Women Tech Makers community and join forces with us so more women are able to get leading roles in technology.
Lunchtime here on the Pacific. My name is Michelle Carney. I'm a senior UX researcher here at Google. And with me, I have my amazing collaborator, Sue. Sue, do you want to introduce yourself?
Hi, everyone. My name is Sue. I'm a tech writer on the core developer relations team. And I'm really excited to be here.
Yeah, we are so stoked because we are going to be going through an introduction to machine learning with you today. And we can look at the next slide too. We really aren't going to be in slides that much. We're actually going to be in a tool called Colab. So I'm going to ask that we navigate on over there and feel free. I know we have amazing moderators to post the Colab in the chat. All of the resources are there. So I believe you can see my screen, but we are going to be covering an introduction to machine learning, and this is really for everyone. So whether you are, brand new to coding and machine learning, hello, welcome. We're so excited to have you here. If you are already an expert, hopefully you'll learn a couple of new things about TensorFlow, which is the major project that myself and Sue work on. But yeah, that's what we're going to be doing today. Okay, I know some of you are probably thinking too, if you're brand new to coding, wait, I thought you were supposed to be in like a terminal with like fingerless gloves and like code screaming by. No, actually, the tools have gotten so much better in recent years. And I think that's one of the things that we really want to emphasize with you all is that you can actually just open up a Chrome browser and go to this tool called Colab, which is really like a Google Doc of Python code. I know that's kind of a little bit confusing, but actually Sue can have this open at the same time as me. We both can be writing code together on this in the browser. And so you don't need to actually set up all those complicated things and terminals. It's really easy to just get started. And we are going to be also talking a little bit about the major steps into machine learning. Sue, do you want to cover some of those?
Yeah, sure. So we will be covering what is machine learning, and then we'll go straight into looking at our code going over the different parts of creating a model, which is prepping your data, training your model, and then finally evaluating your model.
Yeah, for sure. And sincerely, I hope that your ML journey doesn't end when we stop presenting today. I am so stoked, as we talked about in the previous session with the career panel, of like, there are so many of you who are looking to explore careers. And I hope that this inspires you to take up and learn and try some new things, because we're all an expert in something, and machine learning is just a tool to apply our expertise. And so I'm really excited to see how you end up applying it. But for those of us on the line who may be a little bit too nervous to ask, I'm going to ask the question. Sue, what is machine learning? Like, how would you explain it?
So machine learning is basically the process of teaching a computer to learn patterns from data, and then to be able to apply those patterns for new data to make predictions. So if you have programming experience, traditional programming is where you write a bunch of rules that the computer can perform to get the output that you desire. But in machine learning, instead of writing the rules, you provide the computer a lot of different examples of the inputs and outputs that you want. And then the algorithm learns the patterns that it finds in the data, and creates the rules itself. And that's kind of like what it gets produced as a model. And then you use that model to make predictions on new data. So, for example, if you are trying to create a program that converts temperature from Celsius to Fahrenheit, in traditional programming, you would write a code that actually performs that calculation in the equation. But then if you're using machine learning, you would provide a lot of examples of Celsius to Fahrenheit conversions. And then the machine learning algorithm would then find the pattern, the relationship between the inputs and outputs, and be able to derive that equation or something like close to it to be able to produce outputs.
Totally. And I think one of the things too, like we've seen a lot of really great talks about like, where does bias get introduced and all this stuff too. And we'll talk a little bit more about this down below, but this is an example because we're using examples of like what we have observed in the world, and the machine learning model only knows those examples. That is an area of bias. So you can imagine a scientist is out there with a thermometer and they're like, oh, it's 0 degrees in Celsius and 32 in Fahrenheit, write that down. But say they accidentally smudge something, like those accidents totally happen when you're collecting data. And so that's an important thing to remember too, is that sometimes like the data that we're collecting, how you're collecting it matters, who's collecting it. Also too, I want to also mention that you may have heard of other types of ML algorithms too. I think my favorite is always the spam detector emails. Whenever I teach at the Stanford D School, and I'm always like, oh, how would we write a spam detector? And like the most important thing that I stress is that like it is not enough to just know what spam emails are. You also need examples of non-spam emails. Otherwise, if you give all those examples of spam emails to your model's going to think the entire world it knows of, because all the examples it's ever seen are spam emails. So you need equal like spam emails, but also non-spam emails. And also too, if you're interested, we're going to be working with like a structured data set today. But if you want to learn more, especially like we've seen really great examples about image and video recognition or processing, you can actually look into this Intro to ML course. And like I mentioned too, this is all available if you want to follow along and click on all these links. You won't hurt our feelings if you want to follow along while we're presenting this. So,
yeah.
Okay. Phew. Now we can actually get into it. Let's talk about the ML model and data set we're going to use. Okay. These are really cute. Sue, what are we working with?
Yeah, so the data set that we're working with is the Palmer's Penguins data set. And I think earlier Dominique actually used the same data set in her demo. Basically, it's a data set that's structured. And it has, different measurements of different parts of penguins to help identify the species. And so we'll be using this in our model to predict the penguin species.
Love it. Also love that we're using the same data set as a celebrity. Like what?
Right.
One of the things that I really want to stress, I love this image of it because one of the things that, like, the first thing I thought of when I looked at this data set is like, okay, I don't understand bill length or bill depth or anything, but you can kind of see like, oh wait, the Adelie, oh, it's drawn with the shorter bill and all this stuff too. And it really helps you understand, all of these individual rows of penguin observations are actual individual penguins that we're going to see. So how cute is that? Perfect for the holidays. And we're going to be using a decision tree algorithm that is, I think, one of my favorite types of algorithms because it's just very easy to understand how the computer is choosing to make splits in the data to determine different types of penguins is what we're going to be asking it to do. But it could also, you could do it on different types of variables too. I'm sure at some point you've heard, oh, machine learning is a black box. Well, decision trees are actually a really great way to see exactly what the computer is deciding are optimal split paths for your data to determine different things that you're asking of it. For instance, maybe we're like looking at like type 1 as a chin strap penguin. Like it might just be like, oh, the size of bill is greater than this. If it is, then it is a chin strap. Oh, we did it. And then also we are going to be using decision forests, which are a type of ensemble method of a bunch of decision trees. But before I move for Sue to explain it, you can go ahead and run this pip install down here, and it'll go ahead and load that. Sue, what are decision forests?
Yeah, so like you're saying, it's a machine learning, a family of machine learning algorithms that uses decision trees as the building block. So essentially, instead of just having one tree, it uses a lot of different trees, hence the word forest, and it to make predictions, it uses the results from each of those trees and then somehow aggregates them, whether taking the majority vote from all the trees or averaging all the results, and then getting that, using that as the output. So yeah, we're going to be using the TensorFlow decision tree forest, which you just started, Michelle just started installing. It's a library that provides these model algorithms and makes it a lot simpler to create your models without having to understand all the different parts that go into it.
Totally. So if you want to read a little bit more, it's up over here. I also want to stress too that a lot of these machine learning models, when we talk about training models and everything, it is not people like going to the gym with their models and like training them or whatever. It's like these models, a lot of them have already been written by machine learning scientists. And what they have done is actually write the equations that can help understand the trends in your data. And what you can do is then apply these already existing models and libraries. There's going to be a couple other libraries that we want to run along with this to find those trends and patterns in their data. You don't need to know exactly how to code, but you need to understand what the code can do. And that's something too that I really want to stress with you all is like, the secret is a lot of times when I'm coding my data science and machine learning algorithms, I'm looking at Stack Overflow, I'm looking at TensorFlow community forum, and I'm seeing kind of how are other people using this and how do I do those best practices. So on that, we are going to be using a couple other libraries that are pretty common along with TensorFlow, including pandas, and we're going to be loading our library into a pandas data frame, which if you're familiar with Google Sheets, it's very similar to that. It kind of structures your data already. Okay. Speaking of data, okay, we already mentioned we're going to be talking about penguins, but it's important to understand too, like Sue and I did not collect this data. Dominique did not collect this data. This was collected by someone else. And you can imagine their motivation, like why they might collect it, where they might collect it might be different than if Sue and I, us penguin enthusiasts, were out there collecting information. It might be like, is this penguin cute or not? No, just kidding. All penguins are cute. We already know that. But the zoologist might have, or this researcher might already have like a question in mind that they're trying to measure, right? And that's not always captured in the data itself. So that is important to remember is like, what are some things that might be missing from this data? What are some things that we should be thinking of in the back of our mind of like, oh, these were only collected in these islands. It doesn't collect all the penguins ever. Another thing is too that ML models, while they are learning, they only learn on those examples, like what Sue was showing earlier with the Fahrenheit and Celsius. So we need to make sure that those, the data that we're feeding it is readable by the machine. So that means sometimes it might look like the number 5, but we need to actually make sure the data is read in like a number 5, so the machine can do math on it. But the other thing is too, it doesn't answer questions about things that it's never seen before, right? We talked about spam detection, not spam detection, but if we ask this model like, oh, what is the average size of a hippo? It probably couldn't answer that. Actually, it definitely couldn't answer that because there are no hippos in this data set, right? So something to think about. I am now going to load in this data set. The other thing that I want to emphasize too is that the TensorFlow data set, there's a lot of really great data sets that already exist that are semi-structured if you just want to get started and play around. Sue and I chose this penguins one because we both love penguins, but there's so many others. Sue, is there anything that you want to say about this data set?
So looking at the data set, so Pandas has a method that called head that lets you kind of look at a sample of the data set. And looking at the data set, it looks like the type of data that we have is where the island that they're from, I'm assuming, the build length, depth, flipper, length and body mass, sex, and the year.
Yeah, I wonder what year means. Like
right,
one of those examples, like is year the year it was born? Is year the year it was recorded? Like, I don't really know what year means in this context.
Yeah. Yeah, and like, yeah, it'd be interesting to see kind of like how what the spread is of that data.
For sure. And like I can see why that might be important if you're looking at Adelie penguins across 2007, like trends, or 2007 to 2017. But if it's just like, oh, all the Adelie penguins were recorded in 2007, that doesn't necessarily give me the information about how it might compare to the other two types of penguins. Right. Also, I see this like NAN. What is this? Do you know?
Yeah, so I think that means that the data is missing for that particular penguin. Mm-hmm. And that's something we should probably think about in like cleaning and updating the data for the model for the training. And there's lots of different ways. Yeah.
Yeah, the NAN or not a number or null values can be pretty common in different types of data sets. Like we mentioned, like you can imagine there's like a scientist out there running around with a little tape measure being like, penguin, come back. I need to measure you. And like, maybe this just didn't get recorded. Or maybe it's something else instead. Maybe it was recorded, but it was smudged, or maybe like it accidentally got deleted, or maybe it's a duplicate. There may be reasons why this is recorded as NAN. And while we don't know right now, there are ways ways of getting around. There's like a whole field of study and statistics around like, how do you deal with missing values and all this stuff too. But you can imagine if this was, say, a census data set and all the null values were for like people missing zip codes, and then all of a sudden you just decide to remove those because you need to get your data to be machine readable, you might accidentally exclude an entire population of people. So the data side of this, I like to joke, is like 80% of doing ML is like looking at your data and asking these hard questions, just so that way you're making sure that you're not putting more bias into your model, or you're kind of understanding like what are some of the trends, or why was this collected. Okay, and if we want to see the entire data frame, by the way, this green part is called comments. Sue and I have written them, so you can imagine us sitting next to you and reading this out. The entire data frame is just DF. That's how we've loaded it in, and you can see that there's 344 rows. Remember that it starts at 0, so sweet. Ooh, Dream Island, dreamy. Sweet. Okay. So we've loaded our data, we've looked at it a little bit, but a big part of doing ML is exploratory data analysis, or just EDA, and 344 like rows is too much to view all at once. So some of the things that we like to do are group bys or summary statistics, or just information about that. Let's go ahead and run this. Ooh, what are we looking at here?
So it looks like it does a count of all of the data by species. And so it looks like chin strap. We have a lot less data examples for chin strap than the other penguins.
Like half as many. But also I noticed that these numbers aren't consistent. I bet you this is because if we look back up here, we saw that NAN, this Adelie penguin, it has the island, but it doesn't have any of those other numbers. And so this isn't like the average length or anything. This is just like, is there a value here? So that's kind of what we're looking at there. So, but if we actually wanted to get those averages, we can just do the mean. Ooh.
Yeah.
Okay. What are we looking at?
This is interesting.
Yeah.
There's, so if you look at like, so first, some of the features are missing. Some of the columns are missing, like island,
Sex,
and sex. Yeah, because they're not numerical features, so it doesn't really make sense, to take averages of them. And then we can see from like, if you look at body mass, Gen 2s are a lot bigger. It looks like.
And we visualize this in a bar chart down below, because sometimes it's like hard. Like I just look at this, I'm like, numbers. I don't know, 3,700 is close to 5,000, right? No, wow. It's a lot bigger. Gen 2s.
Very significant.
Chubby penguins. But also the year, like this definitely doesn't make sense to me now. Like we should definitely drop it when we clean up this data, because what does 2007.97, is that like December, like Christmas time? I don't know.
Right.
So that doesn't seem like it would be helpful if we're just trying to look at the size of the penguin and then predict what type of species it is. So awesome. So yes, visualizing your data is a big part of it. So plotting bar charts and stuff like that. But also you can just pull out individual rows and see like, oh, what's here? And you can change out, looking into your data frame about like, hey, what other rows are there? I want to look at a single row, and let's take a look there. Or you can also see, as we were mentioning, like strings or word-based variables or features versus numbers. We need to make sure, like if it says like bill length in millimeters in the column, that is read in as a number or a float. So it looks like all of that checks out. So woohoo, great. So time to clean our data. So we had mentioned about dropping null values or NAs, and it looks like if we were to drop some null values, I'm looking at the non-null count. So species, we have every species labeled 344, and it looks like the lowest one with nulls is the sex characteristic, which is 333. So that's going to be 11 that we would lose. So I'm just going to say we're going to drop the nulls. Remember, we're going to drop the year, because that doesn't really help us. And let's look at the head of the data again. Sweet, we are missing the year column, but that's good because that didn't really give us that much value. And then we're also missing that one that had nulls for all the Adelie penguins. So, and And now we're at 333 non-null numbers. So ta-da, let's set our data frame to this new clean one. So cleaning your data and determining how you're going to feed it into your model is a big part of that. The other big thing is labels. Sue, do you want to explain a little bit of what labels are?
Oh yeah, so labels are what we call like the results that we want the model to predict. So in this case, we're going to say species. We want the model to be able to predict species. And because for this particular example, we're using the Keras library. It expects integer values for the labels. And right now, as you saw in the table above, our species value is in strings. So that little code snippet there is just converting the strings into integers, 0, 1, and 2, I think. That's all it is.
Totally. Yeah. So from here on out, class 0 or type 0 is going to be Adelie, class 1 is Gen 2, and class 0, 1, 2, Gen 2. Oh, sorry, that threw me off. Class 2 is Bootstrap. Awesome. Okay, but now we know that it's machine readable. Yeah. The other thing is training data versus testing data. I know that we may have heard that before about like, what was this data trained on and all this stuff, or model trained on and all this stuff. So it's really important. We only have this 333 rows of these penguins data, that we don't give all 333 to the ML model to find that mathematical equation and trend on it, because then it'll know exactly that if I give it any of this data again, it'll know exactly what it is because it's seen all that data. It's important that we only give it typically like 70% of the data, and we hold out a random sampling of 30%. So the 70% that we train it on is called the training data, and the 30% that we're holding out is called the testing data. So that way we make sure that this model is performing well, and it's not just like doing a good job on things that it's already seen. We want to make sure it performs well on data it hasn't already seen. And good news, you don't need to code this yourself, because there's a lot of really great already existing splitting data sets or functions and stuff that you can use too. So woohoo, thank you for that. Okay. Yeah. And then to convert it into a way that TensorFlow, our machine learning library, is going to use it, there is just a PD data frame to TF data set. Woohoo, we did it. So we ran that through, and now we have that. Sweet. Okay. Now we're ready to train. Little emoji of working out. But actually, this is like the easiest part of the whole thing, because there's a bunch of already existing libraries. Yeah. So what are we going to train it on?
So we're going to use the random forest model that we talked about earlier. And then we will use the fit method and give it our training data set.
Woohoo. Yes. And so remember, we're using that training data set that we had first set up here, right? We're not giving it all 100% of our data. We're only giving it 75% or 235 examples, or 70%. Sweet. Okay. Well, that was really fast. That literally happened in like under a second. And so like, I know this is always the funny part. Whenever I show my students this, they're like, what? It trained it that fast? It learned? I'm like, yeah, I know. The most of the time you're spent exploring your data, making sure it's set up right. And the cool thing is that because we're using already shared libraries across many other people, things like TensorFlow and Pandas and all this stuff too, all of these models already come with ways to evaluate them. So Sue, do you want to explain a little bit about how we're evaluating this model?
Yeah, so the TensorFlow library has a model, has a evaluate method that you can specify like the type of metrics that you want. And we're saying we want to see the accuracy. And then when you call evaluate, you want to give it the test data set that, because we want to, again, like Michelle said, we want to test on data that the model has not seen. And that's it. And then you could just run the code and it looks.
Okay. And this is another thing that's like my favorite is that because we're using Colab and because we're using TensorFlow, there's a ton of visualizations that you can use. So remember, decision trees are great because you can kind of like look in and be like, what were the split levels that you made? And so reminding us back that class 0 is ADL, class 1 is Gen 2, and class 3 is Chinstrap. We see the first thing that the computer decides on is, what is this? Flipper length millimeters is greater than 206. So if they have big feet or big flippers, then they are, looks like a lot of class 1. Oh, a lot of Gen 2 has big flippers. Otherwise, if they have under big flippers, then the computer says, okay, well, the next thing that I'm going to determine is, does it have a big bill? And if it does have a big bill, then it looks like it's most likely to be that Gen 2. So, woohoo. But the other thing, Sue, do you want to do this next one? I'm changing the tree index right here, which we can change to be another tree to actually, look into how, like, remember a decision forest has a bunch of different trees involved. And so we can actually just see what's another tree. What does that do? Okay, Sue, do you want to take this split?
Yeah, so it looks like this also splits first on the flipper length. And it does a similar split at the of the data set there, and then looks at build depth.
I never thought to measure build depth. Let's see. Let's do a decision tree 5. Oh, build depth. It heard me. No, just kidding. Not hear me. But build depth is the first one this time. Ooh, ah.
And then and then filter length again, the second one. So yeah, it looks like those two are kind of good predictive features.
Yeah, for sure. And also I'm saying over here, island in. So remember that island is still a string. So it's asking, well, is this example, we're not giving it for that test data, we're holding out, we know what the answer is about what type of penguin it is, but it's just saying, given that this has a bill length of this and a bill depth of this, and it was observed in this island. So this is asking, is this penguin, was it observed in Island Dream? Is it a dreamy penguin? So then that is the splits. So woohoo! Congratulations. You just trained your first ML model, probably somebody in the audience. And so, and you can kind of look through and understand how that computer is making those decisions. The other thing that you can do is really understand how well the model is accurately converging on that and how many trees are needed too. So we're showing an example here from Matplotlib where you're actually plotting like, oh wait, if I give it more trees, like, does that mean it'll converge faster and give us a better accuracy? Or the other thing too is log loss. And so I want to speak to people out there who maybe are like, whoa, this is a lot of math stuff. It's okay. There are a lot of great tutorials that are totally free out there. And if you're interested, you could totally learn more. But I think one of my favorite things is actually using TensorBoard, which actually works in Colab too. So let's go ahead and load this. Is there anything else about number of trees or log loss that you want to share, Sue?
I mean, just looking at the accuracy or log loss or the charts, it looks like
it was like, oh, pretty good at 90. Well, you know, the scale is also 95.5% to 97.5%.
So pretty good.
Doing pretty good.
Yeah.
And let me change this to light mode. But TensorBoard is another tool, works with a lot of different TensorFlow models, and also works in Colab, which is the example or the interactive coding web browser that we have. So you can actually mouse over and you can see all the different interactions there. You can do different types of smoothing. You can do different types of loss and accuracy. And it's a really great way to just play around. And if you're like, how do all these things work together to make those differences? Like, you can just try it for yourself and explore it, which I think is really cool. Yeah. Okay. Woohoo. We did it. We got the penguins. We were able to do it. What else can we do, Sue?
So the library comes with a few other models that you can try, and then you can also like the TensorFlow core library also has a lot of other options of that you can try with your data set. So if you want to try just a different decision forest model, then replace like the model name up above where we used random forest with any of those other models, and then rerun the code, and you can see like different examples like how using different models affect accuracy and the performance of your model.
Love that. And I'm going to tell you a secret. This is how most machine learning happens, is that we look at a tutorial that already exists and you actually just go and try it and you try your own things. And I know sometimes that can be a little bit scary because it's like, well, wait, I didn't code it all myself, but like, that's okay. Like you still did a lot of the data cleaning. You still understand, you're asking the questions about it and you're exploring. This is being a data scientist. You're putting on that hat about like, well, which model helps me understand what's going on with my data? So there's a lot of different ways that you can explore that. And if you want to use, like we saw bill length and island, and if you're like, oh, I only want to use those two to train the model, like I don't want to use any of the other features like, I forget what some flipper length or anything like that, you can also just use a subset of the features too. And there's a ton of other free tutorials on that. Speaking of free tutorials, oh yeah, good job. We classified the penguins. Yeah, we did it. But wait, there's more. The fun does not need to stop here. Like I sincerely hope for some of you who are in the audience, and this is like your first time, like really looking at ML code, or maybe for some of you, you might work more like Sue and myself are actually not software engineers. Sue is a technical writer. I am a UX researcher. But we are here to say that it's okay to be curious and to get in there and learn how this code works, because we need people of all strengths, of all backgrounds, of all expertise, helping and understanding to make these ML resources more approachable and just better for everyone. So there's a ton of free resources. Sue, what are some of your favorite free resources?
Yeah, the Colab on developers.com for Intro to Machine Learning is a great foundational course that you can take. And then the Zero to Hero Intro to ML on YouTube is really great too. Like they have very good snippets that kind of take you through like the main ideas, within machine learning. And then if you're ready to code, or, if you're like ready to dive in there, Kaggle has a great community of like other learners and competitions that you can participate in.
We put competitions in quotes because like you all can get a participation trophy. It really is like, how does someone else solve the same type of problem that you are solving, and how might you do it differently? There's just because you are, I know this was something that I really had to get out of when I was doing machine learning. I was like, there must be only one right answer, but actually there's a bunch of different ways to solve these problems with different types of machine learning algorithms. And that's the cool part. You all can solve it differently. And because you have that expertise, you can bring that. Some of my other favorites too are things like from the People Plus AI research team, the Know Your Data tool or the language interpretability tool. And in case you are have any more questions or want to ask anything or just learn from others, I also love the community aspect of TensorFlow. The fact that there's the TensorFlow forum that has so many people who are so passionate about this and getting these resources out there. And truly, like, the community would not be what it is without all of the folks who help make that possible, including all of you new folks who are going to go ask great questions on the TensorFlow forum. Yay. Okay. So that is our whirlwind intro. Congratulations. We've all built a model now. We all know how to classify these penguins. And big thanks to all the folks who helped make this possible. And if you have questions or comments, we'll take them now. Also, you can post them later in the TensorFlow forum. Yeah. Sweet. I cannot see the questions, so I am relying on some folks to ask some questions. Oh, I'm seeing one question come through. Okay, so Sue, one of the questions is, the field of machine learning is relatively new. Like, how did we get into the field of ML?
Well, for me, I have a just an engineering, like a straight engineering background. So I worked as like automation engineer for a while, but I saw like the power of machine learning and like the power of like the application of machine learning, and so I took different online classes and like the types of resources that we shared, participated in that, and then and then got into like a program that's for specializing data science, and got into it that way.
Love it. And now anytime you go to tensorflow.org and you read through the explainable, how explainable and clear our website is, you can thank Sue because she does full writing for it.
Oh my God. There's a whole team of us. Yeah.
Thank you, team. So for me, I got into the field of ML. I actually study computational neuroscience. So very similar to Dr. Vivian Ming, who was our keynote speaker, and we overlapped at Berkeley. So I get it about like, how do yeast synthesize proteins? Like, I love that stuff. I actually was studying cochlear implant algorithms or just like hearing aid algorithms. And just because the model says it's 30% better, you put it in front of people and you ask them, is this better or worse? They sometimes will say, I don't like hear a difference. I don't experience a difference. And that to me is what got me really interested in the UX side of it. Of it doesn't matter if you build a really powerful model. It really depends on how people are experiencing it or if they find it useful. So that is, I studied actually machine learning and all this stuff, but then I ended up going more towards the design and UX side of it. And now I kind of go between, but you do not need to know how to code in order to work in machine learning. And I want to let you all know this now. You need to know what the code can do, but you don't need to know how to code. Another question that we are getting is, do I have to pay someone to use TensorFlow for ML? Like, is Colab, does that cost money? So no, there is no charge for Colab. It is a shared resource, so it like works on your Google Drive. And so if you need like a lot more runtime or anything like that, there are like paid options, but actually you can run it for free. Like today, like you are able to use this URL bit.ly.wiml or WIML 2022 _ intro ML to actually run this collab that we just shared with you today. And no, TensorFlow, sorry. Then the second question, do I need to pay to use TensorFlow? No, TensorFlow is also free. How amazing is that? You can install TensorFlow on your machine for free. It's not just in Google Colab. Like I actually used to run it when I worked on Jupyter notebooks and everything like that too. It's based off of Python. So to kind of understand too, like it is, Python is like a very, very common machine learning language. It's a very common coding language. You can even use it for websites and all this stuff too. So if you're looking to be like, what language should I maybe learn? I'd say Python is a good place to start. And you can just load TensorFlow in that way. And I think that's pretty amazing.
Yeah. There's a question, do I need to be good at math to use TensorFlow? And no, like we were talking about before, like there's a lot of the math that's involved in machine learning and modeling is encapsulated in the library itself, and so you can approach it from like your problem, like defining your problem, and like your understanding your data set. I think is more important to using these libraries than the actual like nitty-gritty math. I don't understand.
Totally. And I think one of the things too is that what we showed you today is basically the common steps that you go through for almost every ML problem is look at your data, do some investigation, ask yourself, does this make sense? And that kind of thing too. We were working with a relatively small data set of like 300 rows. But you can imagine if we were doing like 1 million rows, you kind of want to see like, wait, what are some other trends and all this stuff too that you understand before you just put it into a model and you just take the output as is, right? Like you really need to understand what the data is in order to make like actually concrete decisions on it. But that doesn't mean you need to know all the math behind it. It just means that you need to be able to look up and like some of my favorite resources are free resources like the TensorFlow forum, Stack Overflow, other places where you can just understand like, oh wait, if I look at this number, this is maybe a thing that I should investigate more in, like that kind of thing. So as long as you have the drive to learn, You'll be good. So, and also feel free to ask questions on forums and stuff too, because that's another great way to learn and get yourself out there.
Yeah, and it's a very active community, the TensorFlow forum. Yeah. So.
Yes, it is. It's so nice. We have some questions too about simple ML. So the cool thing is if you have a spreadsheet with data that, like the penguins data that we just used, you can actually use simple ML to do the same type of thing that we just showed you today. So you don't need to do it in Colab, but it is from TensorFlow, and so you can actually go ahead and try that in spreadsheets first. If you're more comfortable with that, like start there. Just go ahead and investigate there. Awesome. And then do you have another question, Sue?
There is. It says, what other types of jobs in the field of ML that are not ML engineering?
Yes, I think both Sue and I are a great example of that. Sue, what are some other types of jobs?
Yeah, there's lots of like being a tech writer, like being on the front end of user experience. I think are great jobs in ML.
Wait, I have a silly question, Sue. What does a tech writer actually do?
Oh, so we write the content, the help content that's available for whatever product we're working on, and the team I am on, we own the content for TensorFlow, so that's a great. That's another example of kind of like a a job that's not exactly like doing data science like on a day-to-day basis, but still very much involved in that community.
Awesome. Yeah. And I sit on the user experience side, or UX is what it's called. And really my job as a UX researcher is to understand, how do our users use TensorFlow and other ML tools, and how do we make it easier for them? So I know there's also I'm going to summarize a couple of different questions around, like, do you need to know how to code in order to work in the field of ML, AI, and data science? No, you don't, but you need to understand how the tools kind of work together. A lot of what I do is like interviews. I sit down with machine learning engineers and I ask them, what does it look like for you to code ML? Can you show me? What are the tools that you're using? What do you wish this tool could do? What are you trying to do? What are some pain points and frustrations? What are you really happy about? I might show them a couple of different preliminary mock-ups of, like, here's a future tool. Would this be of interest? Would it not be of interest? Why or why not? A lot of surveys, that kind of thing too. But you don't need to actually know and build ML and AI models, but understanding roughly like, oh wait, users are trying to do this and they're expecting the data to be outputted like this. For instance, right? The fact that Sue and I just walked through a Colab notebook that is like very similar to how other data scientists work. So that also helps too. I work also with a ton of amazing product managers to help kind of understand, like, wait, hold on, this is what the technology can do, but actually how do we turn it into a product? What are the timelines? What are all the goals we have to do? And technical program managers or program managers in general who also help keep everything on track. And so many other people behind the scenes. So there's a bunch of other roles, as Anitha was mentioning too. You do not need to just be a ML engineer to work in ML. So. Awesome. I know we are close to time. So how about we ask one final question? Okay, so we have a bunch of listeners on the line who are either already in ML, passionate about going into ML, looking to explore. What would be one piece of advice or guidance you would want to give all the people who are listening?
I think for me, like what helped like in my journey the most was, getting involved in some sort of like ML community, and learning from other people, and yeah, and like participating in that, um, in like forums like this, and like other um, other opportunities like that.
Yeah, for sure. I think for me, I know it was like thinking about the one piece of advice I give to people. It was really hard for me because a lot of my teams, I was the only woman in the room. And that, I mean, it's not, trust me, my colleagues are amazing and I think the world of them. But also, if you're spending 8 hours a day with all these people, sometimes you're just like, I would like to see some people who have a little bit in common with me. And so I encourage folks to reach out, find their community and everything like that too. Especially knowing too that we have a very unique opportunity to open the door for others as well, is really big. And when we are able to bring in more people, especially people from different backgrounds, we're able to make products that just are better in general. We're able to find those edge cases. We're able to make sure we're designing because our products are then designed by everyone for everyone. And so, yeah, I think I want to say you are not alone and go find your friends. I know this is why I run a meetup and I really love the TensorFlow community forum. There's a ton of other really great groups out there, especially around women in ML and data science. So yeah. We're excited to eventually cross paths with you one day. So
Yeah.
Thank you so much.
Thank you for attending.